this is actually 4 times the square root of 2. Okay, let's look at the next one. Remember, no radicals in the denominator. So we have a radical in the denominator, 2 divided by the square root of 3. What am I going to multiply by? The square root of 3 over the square root of 3. I have to multiply by the square root of 3 over the square root of 3. This is what the square root of 3 divided by the square root of 3 is just 1. This is just a fancy way to write the number 1. That's all this is. Okay? So this becomes 2 times the square root of 3 over, let's see, the square root of 3 times the square root of 3 is 3. And that's it. It's done. Let's look at example number 3. The square root of 20 divided by 6. Well, let's break up the square root of 20. That's the same thing as the square root of 4 times the square root of 5 over 6. But what is the square root of 4, Andres? What's the square root of 4? So this is 2 square root of 5 over 6. Can I simplify the 2 over 6? Yeah, 2 will go into itself 1 time, 2 will go into 6 3 times. So I actually end up with the square root of 5 over 3. Square root of 5 over 3. Our last example, 2 times the square root of 12 over the square root of 3. So before I multiply both the top and the bottom by the square root of 3, I want to show you that what is the square root of 12 when I break it up as a perfect square times a non-perfect square? Square root of 4 times the square root of 3 over the square root of 3. What do you see you can do? Cancel those out. Do you see that? Do you see how you can cancel those out? So you really have 2 times the square root of 4, which is 2. And what is 2 times 2? 4. 2 times 2 is 4. All right. So let's look at some examples. So today we're going to talk about finding, you're welcome, sweetie. Today we're going to talk about using trig, sine, cosine, and tangent to find the missing sides of a right triangle. To find the missing sides of a right triangle. All right? Dang it. You guys are going to kill me with your bags all over the floor, scattered out. Okay, so it's important that you just kind of just pay attention and absorb this. Okay, so here's the acronym that we use to remember this. So for you guys that are still doing your Desmos, pay attention. Okay, because you're going to not understand this. So this S stands for the sine. So we say the sine function is so, which is the opposite over the hypotenuse. The C stands for the cosine. So the cosine function, ca, is the adjacent, that's the side that's next to it, over the hypotenuse. And the last trig function that we use is the tangent. So that T stands for the tangent, TOA, T-O-A, opposite over adjacent. So you just call it SOHCAHTOA. That's how you remember it. SOHCAHTOA. Okay. So the sine of any angle, this is just an angle measure. Okay, that's all that is. That little symbol is called theta. It's just a Greek letter, right? It's called theta, and it just represents an angle measure. It can be any angle measure, okay? It's just a way to say, hey, that's an angle. So this says the sine of some angle is the opposite over the hypotenuse. The cosine of an angle, the cosine of theta, is the adjacent over the hypotenuse, and the tangent is the opposite over the adjacent. Okay? So the Greek letters that we typically use when we do this are theta, alpha, which really looks like that. It's like a fish, and then beta. Okay? So the first thing that I'm going to do is we're just going to focus on finding these ratios of sine, cosine, and tangent of theta. So I'm going to color this in green because I'm looking at this angle right here. So if I look at angle theta, this angle down here on the bottom, I know that this side right here is the hypotenuse. How do I know that? Well, because it's opposite the, yeah, that's my hypotenuse. Looking at this angle, what side is opposite that angle and what side is adjacent to it? Adjacent means it touches it, opposite means it doesn't. So what side is opposite that green angle, theta? X. Yeah, this is the opposite side. So that means that y is the adjacent side. But what if I looked at it from a different perspective? What if I looked at it from the angle at the top, which is angle beta? Okay. So is the hypotenuse still h? Well, yeah, your hypotenuse doesn't change. It's always going to be in the same spot. But now y is opposite of beta, and x is the side that's adjacent to beta. So the sine of theta, when I think about that, remember sine is the opposite over the hypotenuse. Well, the opposite side, green, theta is green, is x over my hypotenuse, which is z. The cosine of theta, that's my adjacent over my hypotenuse. Well, my adjacent side in green is y, and my hypotenuse is z. Tangent of theta, that's the opposite over the adjacent. So the opposite side in the green is x, and the adjacent side in green is y. So that's when I'm looking at the angle at the bottom. I did theta in green. So now let's talk about angle beta. That's up at the top in purple. So the sine, still the opposite over the hypotenuse. The hypotenuse has not changed, but the opposite is now the side opposite of angle B or angle beta. That's y. So now it's y over my hypotenuse, y over z. Cosine is the adjacent over the hypotenuse. So that's going to be x over z. And the tangent, opposite over the adjacent, is y over x. Okay, I'm going to say one more time. Those of you guys that keep nodding off, I see you. You need to take your hand off of your face because I'm not repeating this lesson and I'm not giving up my time to help you guys when you don't pay attention in class. It's very frustrating. Okay. And this is tough. This is not easy to understand. You guys have never used trig functions before, so it's really important that you pay attention. Okay, so we're going to find some measures. Okay? And we're going to do the sine of theta, the tangent of theta, and the cosine of beta. So let's look at theta, and I'm going to color it green just like we did in the, oh, that's not green. I'm going to color it green, and we're going to label the sides. Okay, so this angle theta right here. What side is opposite theta? What side is opposite of theta? 2. 2 is opposite. What side is adjacent to theta? It touches it. 5. Because we know that the square root of 40 is the hypotenuse. This should have a right angle in it. The square root of 40 is the hypotenuse. So let's think about the sign. Remember, so, ka, toa. So the sign is the opposite over the hypotenuse. So we're going to set up the ratio of the opposite over the hypotenuse. So what is the opposite over the hypotenuse? Yep, you're right. Can we leave that like that? No, we can't. What are we going to do? Multiply by the square root of 40 over the square root of 40. A fancy one. Okay. So the numerator becomes 2 times the square root of 40, and the denominator just becomes 40. Is there a perfect square that lives inside of 40? Perfect squares. 4, 9, 16. Is there 4? So the square root of 40 is the same thing as the square root of 4 times the square root of 10 over 40. But what is the square root of 4? So this is actually 2. And what is 2 times 2? So this really equals 4 root 10 over 40. Can I simplify that? To what? The square root of 10 over, let's see, 4 will go into itself 1 time, and 4 will go into 40 10 times. So that's what the sine of theta is. It's the square root of 10 over 10. We're just setting up proportions. Okay? Let's do the tangent of theta. That's toa. So the tangent is the opposite over the adjacent. What is the measure of the opposite side? 2, and the adjacent is 5. Can you simplify that, or is that good? That's good. You can't, you don't have to do anything to that. There's no radical in the denominator. That's perfect. Leave it alone. Now we're looking at beta. Now we're looking at angle beta. So this is beta up here. And I need to find the opposite. I'm just trying to label them. That means that this is my adjacent because my hypotenuse does not change. The side opposite the right angle is still the same. So the cosine, ka, is adjacent over the hypotenuse. So what is the measure of the adjacent side? And the hypotenuse? Didn't we already solve 2 times the square, or 2 divided by the square root of 40? Yeah, and we got the square root of 10 over 10. So the sine of theta has the same measure as the cosine of beta. Interesting. Well, hopefully you guys saw that. I'm going to move this for a second. I'm going to go back to this. Did you guys notice that the sine of theta, x over z, is the same as the cosine of beta, x over z? The cosine of theta is the same as the sine of beta. And the tangents are reciprocals of each other. Okay, something just to think about. So are we good with this? Okay. So it says find the sine and the tangent ratio of theta. So now our angles have changed. We got a new picture. So theta is up here. This is theta up at the top. So when I think about theta, the side opposite, yep, and the side that's adjacent, and this is my hypotenuse. This is theta, okay? So let's see, the sine, which is the opposite over the hypotenuse. Well, the opposite side is the square root of 12 over the hypotenuse, which is 14. How can we simplify the square root of 12? Square root of 4, square root of 3 over 14. Remember, you want to divide it into perfect squares, non-perfect squares. What is the square root of 4? 2 times the square root of 3 over 14 reduces to what? 2 will go into itself 1 time. 2 will go into 14 7 times. So I end up with the square root of 3 over 7. That's the sine. But I also have to find the tangent. Tangent is the opposite over the adjacent. So my opposite side, square root of 12, over my adjacent side, 2 root 3. I'm going to break up the square root of 12 as the square root of 4 times the square root of 3 over 2 times the square root of 3. Nathan, what do you notice that I can cancel out? What do you see that I can cancel out from the numerator and the denominator? The square roots of 3. So I'm left with the square root of 4, which is 2 over 2. What is 2 over 2 reduced to? 2 over 2 is the same thing as 1. Okay. We're going to do one more. We're going to do the sine and the cosine of beta. So let's go back to this triangle. So here's beta. So if this is beta, if this angle is beta, this is now my opposite. And this is now my adjacent. And my hypotenuse does not change. Hypotenuse does not change. So the sine, which is the opposite over the hypotenuse, is 2 root 3 over 14. Can I simplify that? Yeah, I can divide by 2. So I'm left with the square root of 3 over 14 divided by 2 is 7. So that's the sine of beta. I think I also have to find the tangent, right? Cosine. Sorry, it's sine and the cosine. So cosine, that's adjacent over hypotenuse. So the adjacent side is the square root of 12, and the hypotenuse is 14. But square root of 12 is the same thing as what? Okay, and what is the square root of 4? So the square root of 12 is really the same thing as 2 times the square root of 3 over 14. God bless you. And what is the simplified version? What happens here? Square root of 3 over 7. So if those both have the same measure, what kind of triangle is this? These are 45, 45s, right? Because remember, the square root of 12 is the same thing as the square root of 4 times the square root of 3, which is 2 root 3. These have the same measure. This is a 45, 45, 90 right triangle. Okay. Which of the 3 trig functions must be used for the ratio 9 over 13? So let's look at this. Theta. So if I look at theta, let's label it. What does 13 represent? Hypotenuse, opposite, or adjacent? Hypotenuse. What does 9 represent compared to theta? Opposite or adjacent? What trig function uses A and H? Cosine. The cosine is the adjacent over the hypotenuse, which is 9 over 13. Isn't that what it's asking you to find, that ratio, right? So this is just, what are you going to use? You're going to use the cosine of theta. what it's asking you for. Cosine theta. Okay. God bless you. Find the ratio for the sine, cosine, and tangent functions of theta. So we have to do all of them. So we have to do the sine of theta, the cosine of theta, and the tangent of theta. All right. Sine, opposite over hypotenuse. Let's label our sides. What does 10 represent? A, H, or O? H, hypotenuse. What does 5 root 3 represent? A or O? O. It's O. It's opposite. I said 5 root 3. Yep. And then what does 5 represent? A. So if I want the sine, the opposite, 5 root 3, over the hypotenuse, 10, what can we reduce that to? The square root of 3 over 2. 5 will go into itself 1 time. 5 will go into 10 2 times. Let's look at the cosine. That's the adjacent over the hypotenuse. The adjacent over the hypotenuse reduces to what? 1/2. The tangent is the opposite over the adjacent. What is the square? Anything over 1. You're right, but listen to what you said. You said, would it be the square root of 3 over 1? It would just be the square root of 3. Good job. Perfect. Okay. So what kind of triangle is this? It's a 30, 60, 90. Yeah. This is the long side, opposite theta. So this is the 60-degree angle. This is your right angle. And this is your 30. So 30, 60, 90. Okay. I'm going to do number 1, number 8, and number 18 with you. Not 8. Yeah, I'll do 8. 1, 8, and 18. 1, 8, and 18. So go to page, because your homework is page 8 and page 9. So I'm going to do number 1 with you, number 8 with you, and then number 18. So number 1, it says find the missing side. So this is your angle. Same idea. It's not called theta. Now it's giving you the measure. It's giving you the measure. So let's label our sides. Well, I know that 18 is H. What side is going to get an O? What side is going to get an A? X is the A. That means this is the O. Does everybody see how we do that? This is opposite. This is the adjacent side. The adjacent side touches the angle. The opposite side does not. Okay? So the cosine, because adjacent and hypotenuse is cosine. So the cosine of 69 equals the adjacent over the hypotenuse. We are solving for x. We're trying to figure out the missing side. What do we need to do to get x all by itself? Yep, we're going to multiply both sides by 18. We're going to multiply both sides by 18. So when I do that, I have 18 times the cosine of 69 equals x. We have to put that into our calculator. I want everyone to touch their calculator, pick up their calculator, and go to the mode, press the mode button. Can you guys do that? Yep, go right ahead. Hang on, my calculator's doing crazy stuff. So when you press your mode button, you're going to see if you go down 1, 2 to the third thing, it says radian or degree. You guys see that? we're working with degrees, right? Isn't the cosine measurement that we're given in degrees 69 degrees? So you need to change your mode to say degree. Arrow over to the right, and press enter. Your measurements, the angle measurements that you're working with, are in degrees. That is very important. Okay. So in your calculator, after you do that, you can just hit second quit. It'll save itself. In your calculator, you're going to type 18 times, and then your cosine is that button right above your parenthesis. Cosine, and put in the number 69. Enter. We're rounding our answer to the nearest tenth. So what do you get? X is what? 6.45 makes us, if we round to one decimal, 6.5. If you got 17 something, you're not in degrees. You are still in radians. Okay. You got to be in degrees. And you'll know, because if you're not in degrees, sometimes you'll get negative measures, and we know that we can't have a negative side measure. Let's do number 8. Okay. So from this angle, let's label our sides A, O, and H. What side is going to get an H? 13. What side is going to get an A or an O? A is the blank side. Perfect. So I have measurements on the H and the O. So what trig function uses H and O? Sine, cosine, or tangent? So, ka, toa. Sine. So the sine of 54 equals the opposite over the hypotenuse. How do we get the multiply both sides by 13? So this cancels out, and I have 13 times the sine of 54 equals X. What is 13 times the sine of 54? Yeah, I got 10.51. You put what? Yeah, it's 10.5 is what you should put final answer. That's what I got. 10.517 or something like that. So 10.5. Okay. How we doing? Okay. Number 18. So you guys are not doing 9. Don't scribble them out though, because you're going to do them like this is asking you for a missing angle. This is part of the next lesson. So don't scribble those out. You're just not doing them today. You're not doing 11 or 12. You're not doing 13 or 14. You are doing 15, 16, 17. Choose 2. So you get to choose 2 of these. Does that make sense? So you can either do 15, 16, 15, 17, or 16, 17. I am going to do number 18 with you because I want you to make sure, I want to make sure you understand what's happening. So you're asked to find the area of each triangle. Area of each triangle. And you're rounding your intermediate answers to the nearest tenth and your final answer to the nearest tenth. So I want you to see that you have 2 right triangles. The first right triangle you have is this larger right triangle, which has at least 1 measurement on it. You have 1 measurement. The smaller right triangle doesn't have any measurements, so you cannot start with this. Do you guys see that the red triangle, all it has is an angle, no sides? So you can't start with that. You are finding the area. Remember that the area of a triangle is the base times the height divided by 2. Or you can write it as 1/2 b times h, whatever works best for you. Okay. So I need to know what the height of my triangle is. So I'm going to call that little h for height. Does that make sense? And this whole measurement right here is my base. So I need to know this piece as well. So let's start with the blue triangle. If this is my angle, is this the opposite side or the adjacent side? Is this the opposite adjacent side? Adjacent. What trig function uses opposite and adjacent? Tangent, yeah. So the tangent of 41 equals the opposite over the adjacent. So what? Yeah, we're going to multiply both sides by 43. So 43 times the tangent of 41 equals my height. Yeah, I got it. Yeah, isn't it 0.3 something, like 373? 37.4. So that's the height of your triangle. And I'm going to put that right here so you can see it. 37.4. So now I'm going to go to the red triangle. Okay. Is the 37.4 the O, the H, or the A? It's the O. Is the X the O, the H, or the A? It's the A. So again, I'm going to use the tangent function again. The tangent of 55 equals the opposite, which is 37.4, over the adjacent, which is X. Okay. We have done something like this before. You know that the only way to get X out of the denominator is to multiply both sides by X and then divide by the tangent of 55. You just are trading spots with these. That's all you're doing. You're going to put the tangent of 55 in the denominator and X on the outside. So just do that. X equals 37.4 divided by the tangent of 55. So 37.4 divided by the tangent of 55. What do you get? 26.2. Okay, so that's this little guy right here, 26.2. So if X is 26.2, what is the measure of the whole base? Well, 26.2 plus 43 is 69.2. So the area equals 1/2 times the base, 69.2, times the height, which is 37.4. So what do you get for your area? 1,294.04, right? Is that what you guys got? Who's doing this in their calculator? Did you divide by 2? Yeah. You have to divide by 2 or multiply by 1/2, which is a 0.5, right? So you should get 1,294.0 units squared. Okay, yes or no? 1/2 is the same thing as 0.5. So you guys have 6 questions for tonight. 6 questions of the regular and then 2 of the area. Only choose 2 of those areas, guys. Only choose 2. Okay? So you get to choose 2 of this. Does that make sense? Okay, we're not going to get to that until tomorrow. We'll start class with that tomorrow, your little lemon colored sheet. So just put it away for now. So choose 2 of those. All right.